to have you on Fascinating Frontiers, episode 66, coming to you on May 9th, 2026. Let's look at what's new across the frontiers of space and science. ESA and JAXA have formalized a joint mission to study asteroid Apophis ahead of its close 2099 flyby. The European Space Agency and the Japan Aerospace Exploration Agency signed an agreement this week. Their collaboration centers on the Ramses mission, which will rendezvous with the asteroid well before its rare Earth approach. The partnership strengthens coordinated planetary defense capabilities and improves data sharing between the two agencies. Apophis remains one of the most closely tracked near-Earth asteroids, making this international effort especially timely. The mission highlights how global cooperation can advance our ability to monitor and respond to potential asteroid threats. While agencies prepare for a close encounter with a known asteroid, astronomers have just uncovered something unexpected at the solar system's edge. A tiny icy world far beyond Neptune is holding onto a thin atmosphere despite its modest size. The object is less than a quarter the size of Pluto, yet shows a detectable gas envelope. Astronomers spotted the atmosphere through subtle shifts in the body's brightness and spectral signatures as it passed through sunlight. Temperatures around 40 Kelvin make it difficult for gases to persist against solar wind and thermal escape. The discovery challenges existing models of how small, distant objects can retain atmospheres over long periods. Observations suggest surface ices may slowly sublimate to replenish the thin layer of gas. This raises fresh questions about what internal processes or seasonal cycles could sustain such an envelope where none was expected. That same spirit of questioning assumptions shows up closer to home, where a servicing spacecraft just cleared a major hurdle for rescuing an existing NASA observatory. Catalyst Space Technologies completed critical testing of its Link servicing vehicle. The spacecraft is slated for launch in June aboard a Pegasus XL rocket. NASA awarded a $30 million contract to explore extending the life of a $500 million observatory. The mission marks an early step toward routine on-orbit satellite maintenance and repair. Successful completion of these tests brings the vehicle closer to demonstrating practical servicing capabilities in orbit. Such technology could preserve valuable scientific assets that would otherwise reach the end of their operational lives. While one company readies a servicing mission, another is buying its way deeper into robotics and propulsion. Rocket Lab has completed a $40 million acquisition of Motive Space. The deal brings spacecraft robotics and solar electric drive systems into the company's portfolio. These additions expand Rocket Lab's options for satellite servicing and deep space missions. The move supports a broader strategy of vertical integration across mission components. With new capabilities in hand, the company can now offer more complete end-to-end solutions for complex space operations. As commercial players consolidate capabilities, governments continue releasing new data on unexplained aerial sightings. The Pentagon has released nearly 30 new declassified videos of unidentified aerial phenomena. The footage shows objects of various shapes, including football-like forms and irregular white lights. This release forms part of the Department of Defense's ongoing documentation effort. No analysis or conclusions the videos in this batch. The continued release of such material reflects a growing emphasis on transparency around these observations. While attention turns to what we cannot yet explain, another nation has quietly aligned itself with the framework for future lunar exploration. Paraguay has signed the Artemis Accords. The South American nation becomes the latest country to join the US-led Principles for Lunar and Planetary Activity. The agreement supports Paraguay's goals for technology development and international space partnerships. By signing, the country positions itself to participate in collaborative exploration efforts beyond Earth. New partners are joining exploration frameworks just as fresh surface data arrives from worlds far beyond our solar system. Detailed observations of a distant exoplanet's surface features have now been released. Combined wavelength analysis produced the new data on surface composition and atmospheric interactions. These measurements provide tighter constraints on what conditions exist on planets outside our solar system. The work expands the range of properties astronomers can reliably determine for such distant worlds. While exoplanet data improves, launch vehicle designers are already preparing the next generation of rockets needed to reach such worlds. Several next-generation rockets are advancing with higher payload capacities and reusability goals. These vehicles aim to support both crewed and robotic deep space exploration later this decade. The focus remains on building broader infrastructure rather than single-mission solutions. As launch capacity grows, researchers are also flagging a quieter but critical risk for future Mars landings. A recent study highlights the risk of forward contamination during human missions to Mars. Crewed landings could inadvertently carry Earth microbes to the Martian surface. The analysis calls for updated planetary protection protocols before such missions proceed. Revised standards will be essential to preserve the scientific integrity of Mars exploration. You know what's fascinating about this tiny distant world holding an atmosphere? If Pluto were scaled to the size of a grapefruit, this body would be no larger than a lemon. Gravity on such a small object is weak, so gas molecules should reach escape velocity and drift away. Instead, the atmosphere appears replenished by slow sublimation from surface ices that have stayed cold enough over billions of years. Temperatures near 40 Kelvin allow trace amounts of nitrogen or methane to linger between solid and gas phases. The exact balance between escape and replenishment remains unclear, leaving astronomers wondering which internal heat source or seasonal cycle keeps the layer intact. Next time, we'll be watching for updates on how these new international partnerships and servicing technologies begin to shape upcoming missions. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.